Hello everyone and welcome to the lecture on kubectl namespace commands. So first we'll set the alias k equal to kubectl. So the first command is list namespaces. So k get ns. So this will list all namespaces in the cluster. So the output will look something like this. You have the namespace name, whether the namespace is active or not, and what is the age. So this is in days. So create a namespace. So k create ns followed by the namespace name. So this creates a new namespace. An example, k create ns staging, and output will be namespace staging created. Describe a namespace. So k describe ns followed by the namespace name, and this shows detailed information about a specific namespace like labels, annotations, status, resource quotas, and limits if set. So example, k describe ns production, and output will look something like this. You have the namespace name, labels, annotation, status, and any resource quotas, any limit ranges. Next is to show labels. So k get ns and show labels. So this shows all namespaces and displays their labels. So the output will look something like this. You have the namespace name, status, age, which we have already seen, and all the labels. So for example, this particular namespace development has this particular labels, team, front end, and all others. So this will be a comma separated value of labels. Get namespace using labels. So k get ns, and we have the label sector. So we provide the label and the value. So this is a key value pair. This will list namespace that has the specified label and value. So example, k get ns and -l team equal to backend. So this will only show namespaces which has this particular key value or label set. Next is to label a namespace. So k label ns followed by the namespace name and key value, that the label that you want to assign. So this adds a label to a namespace. So example, k label ns, and there is a development namespace, and I am saying Istio injection equal to enabled. So I am assigning this label. So output, you will see that it is labeled. And if you want to verify k get ns, now you can provide direct namespace name and show labels. So the output, in the output you will see labels column and Istio injection equal to enabled followed by the other labels. So there are two more labels which is assigned to development namespace. Get namespace YAML. So if you want to check out the YAML, k get ns namespace name o YAML output. So retrieves the YAML manifest of a specific namespace. So example, k get ns production o YAML. So output will look something like this. So you have the complete YAML, backend YAML. So this has namespace, and these are the labels, and all other metadata will also be there, like status, phase equal to active. Next is to create resource quota. So k -n, so followed by the namespace name, you can create a quota and name of the resource quota, and you will provide all the quota values. So hard CPU, memory, and number of pods. So I'll include one example. So a resource quota object provides constraints that limits the aggregate resource consumption per namespace. It can cap the total amount of compute resources, which are CPU, memory, storage resources, and the count of objects like pods or services. So here is an example. So kn development, this is only for development namespace. So for development namespace, I am creating a quota which is super quota, and we have some hard limits like number of CPU is 10, request for memory is 20 GB byte. So these are the request limits, and CPU limits. So these are minimum and these are maximum. CPU limits are 20, and this is 40 GB byte. Then request for storage is 500 GB byte. Persistent volume claims you can have up to 25, and goal storage. So if there is a specific storage class, you can request maximum up to 100 GB byte. Number of pods that can go is 50. Number of config maps 100. Secrets 100. Number of services are 20. Number of load balancers that you can have is 5, and number of service which has node ports equal to 10. So this is for this, inside this development namespace, this quota will be applicable. So output will be like, okay, a resource quota, super quota created. And if you check out the resulting YAML, this will be all the hard limits for this particular namespace development. And this is what we have specified. So for example, a compute resources. So request equal to CPU, which is the sum of CPU request for all pods cannot exceed 100 cores within that namespace. The sum of memory requests for all pods cannot exceed 20 GB byte. The sum of CPU limits for all pods cannot exceed 20 cores. The sum of memory limits for all pods cannot exceed 40 GB byte. And storage resources. So request.storage 500 GB byte. The sum of storage size request for all persistent volume claims cannot exceed 500 GB byte. Persistent volume claims. The total number of persistent volume claims cannot exceed 25. And this is a specific class, a specific quota just for gold storage class. And out of the 500 GB byte, which is here, only 100 GB byte can be from this premium class. Next is the object count quota. So you can have a maximum of 50 pods which can exist in that namespace, a maximum of 100 config maps, a maximum of 100 secrets, and a maximum of 20 services. And then we have some specialized quotas as well. This limits the number of services of type load balancer to 5. This is important for controlling cloud cost. And service.node ports equal to 10. This limits the number of services of type node port to 10. This is important for managing port allocation on nodes. Next is to create a limit range. So k-n namespace name and create limit range. You will provide a limit range name and the flags. So in this case, min CPU equal to 100 millicore, max CPU equal to 1. So I'll include one example. A limit range object enforces resource constraints on individual objects within a namespace. It can set default, minimum and maximum CPU or memory request and limits for containers. So this is specifically for containers. So you have pods, but inside that pod there will be containers. So this will only limit the what containers can consume, and this ensures that no single pod consumes excessive resources. So here is an example. So k-n development create limit range object. So this is the name of the limit range object. I am saying min CPU will be 50 millicore for a container, pod container. Memory minimum will be 32 MB. Max it can take up to 2 CPU. This is 2000 millicore. So 2 is 2000, 1 is 1000. Memory 4 GB byte, and default CPU which they can get is 200 millicore, and CPU and memory will be 256 MB byte, and default request will be CPU equal to 100 millicore and memory 128 millicore. So I'll explain that in below. So this will you will get a message saying that it's created, and this is a resulting YAML. So these are, you can directly create if you have this file also. So breakdown of all the flags and what they do. So these rules apply to every container created in the development namespaces. So first one, min CPU 50 millicore, memory 32 MB byte. So this sets the minimum allowed CPU request to 50 millicore, and this sets the minimum allowed memory request to 32 MB byte. Next is the max CPU and memory. So this sets the maximum allowed CPU limits to 2 cores and sets the maximum allowed memory limit to 4 GB byte. And lastly, we have the default request equal to CPU and memory. If a container is created without specifying a CPU or memory request, it will automatically be assigned a request of 100 millicore CPU and 128 MB byte. So this is the default. If this is not, so this is the limit, you can stay within that limits. But if you don't provide, this is the default that you will get for a pod container. And if a container is created without specifying a CPU or memory limit, it will be automatically assigned a limit of 200 millicore CPU and 256 millicore memory. So sorry, this is a request. So this is the minimum and this is the maximum. So request is the minimum and this is the maximum. So if you don't provide these values, this will be the default. But if you provide some value, those values must be in this range. So without any value, this will be the default that will be given. So this is a minimum and the min and max. If you provide, it should fall within this range. So this is what it means. Next, if you want to view the config, so you can say kconfig view. This shows the current kubectl context and the namespaces it is pointing to. So this will be the complete YAML. So it contains clusters, and we have 3 clusters and they have a name. Then we have context. So context is a combination of cluster and user. So cluster will refer to here, name section, name, for example here, and user will come below. So we have this context 1, 2, 3. So this is an array, and you will have a current context. What is the current name context you are working with? And then you have a user. So this is a GKE dev user and EKS prod admin and AKS stage user. So basically, if you have multiple cluster, you will have only one cluster context. But if you have multiple context and you work with multiple cluster, you can say kconfig view and you will get the complete YAML of all your clusters and context. If you want to list all context, you can just issue this command kconfig get context. So this will list all available context in the kubeconfig file, and so it will show current. So whatever current context, there will be a star or a asterisk sign. So currently I am on dev context, and this dev context is pointing to GKE dev cluster, and this is the user which I have authenticated with. And if there is a no namespace, that means this is the default namespace. But if you switch from here to here, it will go to this production namespace. If this is also blank, then it will go to default. If this is also blank, every time you switch context, it will either go to that namespace, or if there is nothing, that means it's a default namespace. So let's say I have run a list context. Now I want to change the default namespace in my current context. So kconfig, I can do set context current. So I'm saying current set context, change the namespace name, default namespace name, and I'm switching to production. This sets the default namespace for the current kubectl context. Then subsequent commands without -n will target this namespace. So basically, you don't have to provide -n if you just change it by this command once. So it will saying that dev context is modified. You are still on the same context, but now it is not default namespace. It will be default is production now. So you can just verify by doing a get context, and you will see this part has changed. So it's showing production. It was earlier blank. If you want to switch the context, you will do kconfig use context, and I'm changing from dev to prod. So get context will show current one and use will switch. So switches the active kubectl context to the specified one, and you will just get a message saying that switch to context. You can verify by running kconfig get context, and you will have an output like this. So you can see this has moved from here to here, and by default this namespace is production. So any command you issue, you will have a production. But if you want to do in some other namespace, you can provide -n. If you want to delete a namespace, so k delete ns followed by the namespace name, and this deletes a namespace. Example, k delete ns staging. You get an output saying that it's deleted. You can verify by doing a k get ns again, and output will be that staging will either be deleted by this time, or if there are a lot of objects into it, it will be going into terminating state. So when you delete a namespace, all the deployments, services, all the namespace object will be deleted one by one. So this is a bit risky operation. Only do if you are sure that you are okay to delete everything inside that namespace. And that's all. Thanks for watching.